Greetings, Dennis Daniels here. Let's talk a little bit more about factoring binomials.
Okay, let's talk a little more about factoring binomials. And let's take a problem that looks like this. X to the fourth minus 144. You're going to see that there's a little bit of magic happening already if you know your multiplication tables. First, we know since it's a binomial, we're going to have two sets of parentheses. We know that we're going to need x and an x here. We know that 144 is the square of 12, so we know that 12 goes in there. We know that there's that we're going to need a negative and a positive. The question is, what do we do with this 4? Well, since we're just factoring binomials, it means we're just going to put a 2 here and a 2 here, and that gives us our answer. We have now factored this binomial. Now keep in mind, these are perfect squares. That any variable, here's our variable x, taken to an even power, here's our even power, 2, equals, it is, means that it is x squared is a perfect square. Alright, thanks for watching.
Alright, now let's take a look at this x to the fourth minus 144. What do you think it's going to look like when we put it in for graphing? X to the fourth minus 144. Take a look at it. I'm going to do its computational genius. Alright, there's the alternative forms right there. There's the parabolas. You see how it's kind of squat at the bottom, right down there. And there's the alternate forms. There's the real roots. And there's the complex roots, the imaginary numbers. There's some roots in the simple plane, discriminants, derivatives, indefinite integrals, global minimums, indefinite integrals below the axis, etc. So you can see that once you begin to understand what's happening with these numbers, there's a lot more going on than just numbers on a page. To that point, let's take a look at number 144 since we're here. And I wanted to share with you 144. There it is, 144. There's the Roman numerals for it. CXLIV, binary form. And what I wanted to share with you is that 144 is also a perfect square. So lots of perfect squares when you start looking for them. Thanks for watching, and happy computing.